Welcome to Thermochemistry, and today we're going to look at fuels and how to calculate kilogram calorific values. Fuels are a substance which, when oxidized, release energy. Organic-based compounds are common fuels, and air is a common oxidizing agent. The burning or combusting of organic fuels in air will produce products such as carbon dioxide and water. The burning of fuel is a chemical reaction in which chemical energy is converted into heat. There is a wide range of materials that are classified as fuels. For example, fossil fuels, oil, gas, turf, otherwise known as peat. The different fuels can be compared in terms of their energy efficiency by comparing the energy released from combusting the same mass of each fuel, and typically this would be done on a kilogram scale. The energy released per kilogram is known as the kilogram calorific value. I have listed below some common fuels and their associated kilogram calorific value. Peat is 18 by 10 to the 3 kilojoules per kilogram. This value can be converted to megajoules by dividing it by 1,000. So I would have 18 megajoules per kilogram. Coal is 33.5 by 10 to the 3 kilojoules per kilogram. And hydrogen is 142.9 by 10 to the 3 kilojoules per kilogram. So what these values tell us is, if I combust or burn a kilogram of any of these fuels, I can see when I compare peat to hydrogen, hydrogen releases far more energy when compared to peat. So the kilogram calorific data is often obtained by burning a small sample of each fuel and scaling up the energy released in the experiment to give the energy value had a kilogram of the substance been burned. Let's have a look at a worked example. If 55 grams of a fuel releases 8,400 joules of energy on combustion, what is its kilogram calorific value? So we know that 55 grams releases 8,400 joules. So let's find out what 1 gram releases, and we do this by dividing our energy, which was 8,400 joules, by 55. That brings it to 1 gram. And then to bring it to the kilogram scale, we just simply multiply that value by 1,000. And the answer we get is 152727 joules. We want to change joules then to kilojoules, and we would do that by dividing this value by 1,000 to bring it to 152.727 kilojoules per kilogram. Now there's a second way you could have done these calculations, and that was to change the 55 grams into kilograms, because remember, you want your final answer in kilograms, so it's kilojoules per kilograms. So I can change my 55 grams into kilograms, and the answer would be 0.055 kilograms as the equivalent. And that is equal to 8,400 joules. To find out what 1 kilogram is, then you simply divide your 8,400 joules by 0.055 kilograms, and you will get the answer just like you did above, of 152.727 kilojoules per kilogram. So here's one for you to have a go of. If 58 grams of butane releases 2,880 kilojoules of energy on combustion, what is its kilogram calorific value? So pause this video, have a go, and the calculations will be on the following slide. So the calculations are as follows. 58 grams releases 2,880 kilojoules. Let's find out what 1 gram releases. We do this by dividing our 2,880 by 58. Then to find out what that value would be in kilograms, we simply multiply that answer by 1,000. And the answer we get is 49655 kilojoules per kilogram. So that's how we work out the kilogram calorific value. And that's it for today. Thanks for joining me.